Okay, at this point, I have a blank slide here, and I'm going to write down my data and the information that we need to solve this problem, okay? I made up this data and back calculated it so that you would have different data from me, okay? So my mass that I am using of sodium chloride, I'm going to say I had 6.570 grams, okay? My volume is still 100 milliliters, okay? And my I is going to be equal to 1.9. So the I, or the Van Hoff factor, is 1.9 for sodium chloride, okay? All right, so the mass of the water is equal to 100.0 milliliters, and that's 0.997 grams per milliliter. So that's equal to 99.70 grams, and that's equal to 0.0997 kilograms. Okay, my delta T, and again, I made these numbers up, is 101.097. So that was the boiling point that I'm using for my water. It's not the one in the video. Minus 100.0, that's the boiling point for my pure water. And that gives me a delta T for this example of 1.097 degrees C. All right, and we know that delta T is equal to Kb for water times M times the Van Hoff factor I. So M is equal to delta TB divided by Kb times I, which is equal to 1.097 degrees C divided by 0.5, oops, messed up there, 0.512 degrees C per mole. That's the Kb for water times 1.9. Okay, so that's on the denominator, and that's 1.1277. That's my molality. So that gives me the molality for my solution. Okay, and we know that molality is equal to moles of solute per kilogram solvent. And so that's equal, I'm going to set that equal to my molality that I just calculated, 1.1277. All right, so I need the moles of solute because molar mass is equal to grams per mole. So I'm going to solve for moles of solute, and I calculated my kilograms of solvent here. All right, so the moles of solute, okay, is equal to, I'm going to multiply the 1.1277 times the kilograms of solvent, which was 0.09970 kilograms. Okay, so this is the molality times the kilograms, which is equal to 0.11243 moles. So that gives me the moles of solute that I had in solution, okay? And so the molar mass of sodium chloride for my calculation is equal to, I had 6.570 grams divided by 0.11243 moles, okay? So that's equal to 58.435 grams per mole. All right, and so that is the molecular weight that I have calculated, the molar mass that I have calculated for sodium chloride. Now, from the periodic table, we can find that the correct molar mass for sodium chloride is 58.443. So that is the molar mass of sodium chloride. That's the atomic mass for sodium plus the atomic mass for chlorine. That gives us 58.443. So I want you to calculate the percent error, which is equal to the absolute value of 58.443, which is the true value, minus the 58.435, which is the value that we got from our experiment, divided by the true value, which is 58.443 times 100, which gives me a percent error of 0.0137%. Okay, so that is my percent error. So I would like for you to complete your calculations and put them into the lab. Thank you.